When solving compound inequalities, you will use the same steps as solving regular linear equations, except your goal is to isolate the variable in the middle of the compound inequality. And if you multiply it or divide by a negative number, the inequality symbol needs to be reversed. Solutions to inequalities should also be graphed in a number line with the solutions written in set-builder notation or interval notation. For this video, we are going to look at solving compound inequalities. Compound inequalities have 3 parts instead of 2. So when you're solving anything, you do to one part of the compound inequality will need to be done to the other 2 parts of the compound inequality. Similar to a regular equation, if you do something to one side, you do it to the other. A compound inequality has 3 parts instead of 2 sides. So if you do something to one side, you have to do it to all 3 sides. In this example, first notice that we have a fraction in the middle here. We need to make that fraction go away. We can multiply everything in the compound inequality by the least common denominator, which is 4, for this to happen. This will look like 4 times your negative 5 less than or equal to 4 times the expression in the middle less than 4 times 6. Notice I did not reverse any of the inequality symbols because we multiplied by a positive number. Now we can go back and do our multiplication. 4 times negative 5 is negative 20, which is less than or equal to your middle portion. These 4's cancel because this 4 is over 1, so these will cross cancel. And we are left with 3 minus f, which is less than 4 times 6, which is 24. Now our fraction has gone away. So we need to recognize that in a compound inequality, our goal is to isolate the variable in the middle. So we need to move this 3 away from the game and subtract these 3 from all 3 parts of the inequality. This gives us negative 23 less than or equal to, those will cancel, so we get negative f, which is less than 21. Now we need to realize that we do not want a negative 1 in front of f. So to make the negative 1 go away, and we know we have a negative 1 because of this negative symbol right here, we multiply the entire expression by negative 1, and that will change our signs. So negative 1 times negative 23 will give us a 23. Negative 1 times negative x will give us a positive x. And since we're multiplying by a negative 1, we will reverse this symbol around. And it will look like that. And then negative 1 times 21 will give us a negative 21. Notice that I reversed the symbol there because I multiplied by a negative 1. Now if we want to look at this in numerical order and have the smaller number of negative 21 on our left side, we can actually just take this entire expression and flip it over. That will look like negative 21 is less than x, which is less than or equal to 23. Notice that this is the same expression because the 23 is going to be larger than the x, and we still have the 23 being larger than the x because it opens up towards a larger number, and the x is larger than the negative 21, which means that the inequality has to open up towards the x, and it still does that when the negative 21 is over here. Now that we have our expression, we need to go ahead and graph this. So we'll make a little bit of room to graph this. And our solution came out looking like that. On a number line, that means that if we're in set building notation, at negative 21, we will have an open dot because we do not have a line underneath the inequality that's next to our negative 21. At 23, which will be up here, we will use a solid dot because we have a line under the inequality that's next to 23. And then we have to figure out where we shade. Well, if you look at your expression here, the x's are larger than the negative 21. That gives you the values over here. At the same time, we have to have the x smaller than or equal to 23, or smaller than is this direction here. So notice that this is going to be an expression where we will be shading in between. Do not assume that you will always be shading in between. Sometimes your inequality will have you shading out here and out here, and those will be written slightly different. So in interval notation, this is going to be a round bracket, negative 21, comma, 23, with a square bracket. Round bracket goes with the inequality symbol without the line underneath, and square bracket goes with the one that you have in a line underneath. The set notation, you take your statement, put a straight line, an x, because that's our variable, and then surround the whole thing with set brackets. Now, also notice that our graph is slightly different from interval notation. In interval notation, instead of an open dot, use a round bracket right at the negative 21, and a square bracket right at your 23. You still end up shading in the same section, but it will look slightly different. And this is how you will end up solving a compound inequality. Your main goal is to isolate the variable in the middle, and then when you're done, you have to interpret your solution into either a graph in set notation, with set building notation for your solution, or a graph in interval notation with interval notation written for your solution. Let's take a look at how this compound inequality will differ from the last one we looked at. For this one, first notice that we need to isolate the variable in the middle, and there's a 2 in front of it. So let's divide everything by 2. Since we divided everything by a positive 2, we do not need to reverse our inequality symbols. So this will give us negative 5 greater than x, which is greater than 4. Let's take a look at what the graph of this will look like. The graph of this, you're going to locate negative 5 on the number line, and you're going to locate 4 on the number line. Then you need to interpret what each part of the expression means. For this part right here, it's saying negative 5 is greater than x. If negative 5 is greater than x, we need to shade this direction. So notice that on your number line, that's going to make you have a round bracket in interval notation, since we do not have a line under our inequality, and we're going to shade everything this direction. Looking at the other part of the inequality, notice it says that x is greater than 4. Well, right here, 4, to be greater than 4, you go this direction. So since we don't have a line under the inequality, we're going to do a round bracket at 4, and we're going to shade everything this direction. Since these are disjoint sets, in interval notation, you're going to go from left to right, and the first thing you come to here is negative infinity that is part of the shaded section. So we will use negative infinity, a comma, and the last thing we come to is the negative 5. So negative 5, which is a round bracket. That just takes care of this side of your graph. When we look at this side of our graph, the first thing that we come to is 4, and it has a round bracket. And then we continue off into infinity. so we put a comma and infinity. Since there is no overlap with these two sets, we use a union symbol between them to say that the solution is either this section or this section. This union symbol is like saying or. If we were to use set notation, the only difference in the graph would be round or open dots here and here at -5 and 4. And your notation would just be your solution dot here with a straight line for such that, and then x and such a variable with set brackets around it. This is red, the set of all x such that -5 is greater than x, which is greater than 4.